Electromagnetic induction. The effect of producing electricity from magnetism was discovered in 1831 by Faraday, and it's called electromagnetic induction. Faraday noted that whenever there is a relative movement between the coil and the magnet, no matter which one moves, an electric current arises. Look at the diagram. The Faraday's law states that the induced voltage in a circuit is proportional to the rate of change over time of the magnetic flux through that circuit. In other words, the faster the magnetic field changes, the greater will be the current and therefore the voltage induced in the circuit. The direction of the induced current can be found by a law stated by the Russian scientist Lenz. Lenz's law states that the direction of the current induced in a conductor by a changing magnetic field is such that the magnetic field created by the induced current opposes the initial changing magnetic field which produced it. Pay attention now. As the magnet approaches the coil, the magnetic field increases and the changing flux enclosed by the coil induces a current in the coil. As with all currents, the induced current creates a magnetic field around itself, and this magnetic field created by the induced current must oppose the initial changing magnetic field which produced it. The current in the coil makes a magnetic field that pushes the magnet. The right-hand grip rule shows how the current must flow. When the magnet is moved away from coil, the induced current creates a magnetic field around itself, and this magnetic field created by the induced current must oppose the initial changing magnetic field which produced it. The current in the coil makes a magnetic field that pulls the magnet. The right-hand grip rule shows how the current must flow. Therefore, the direction of the induced current is reversed. There is no current when the magnet is at rest. The induced current produces an induced voltage if the conductor is connected in a complete circuit. Changing the direction of motion of the conducting wire or changing the polarity of the magnetic field will change the direction of the induced PD and reverse the direction of the induced current. Inducing a PD or a current in this way is called the generator effect, because this is how we generate electricity. The alternator. The alternator is a simple electricity generator. Figure below shows the design of an alternator that consists of a coil of wire rotating in a magnetic field by some external source of kinetic energy. This causes a PD to be induced between the ends of the coil. The diagram shows the design of a simple electricity generator. By turning the axle, you can make a coil rotate in a magnetic field. This causes an induced current or a voltage induced between the ends of the coil. As the coil is turning counterclockwise, the AB wire movement is downward. We know that the current in the wire makes a magnetic field that pushes the wire in the opposite direction of its movement. So the current in the wire makes a magnetic field that pushes the wire upward. If we use Fleming's left-hand rule, we find the direction of the current. The rotation goes on, and the diagram shows the coil rotated in 180 degrees. And now AB side of the coil moves up. So the current in the wire makes a magnetic field that pushes the wire downward. If we use Fleming's left-hand rule, we find the direction of the current. The induced current reverses direction. As one side of the coil moves up through the magnetic field, a current is induced in one direction. As the rotation continues and that side of the coil moves down, the induced current reverses direction. This means that the alternator produces a current that is constantly changing. This is alternating current, or AC. The dynamo. A dynamo works like an alternator in that the coils are rotated through the magnetic field by some external source of kinetic energy. Look at the diagram. However, unlike the alternator, a dynamo has a split ring commutator rather than two separate slip rings. The split ring commutator swaps the connections every half turn, so the current keeps flowing in the same direction, direct current generation, DC.